Hey, physical science. It's Monday, April 27th. We're going to finish section 3, chapter 16. Take a look on page 498. If you take a look at this little actual replica of Mendeleev's first periodic table, if you turn your book on its side like that, you can see that his was built just opposite of ours. And if you look right there, you're going to see lithium, and then sodium, and potassium, and rubidium, and cesium, just like ours is in first period. Did you enjoy that video on YouTube with the alkali metals being thrown into water? Okay, now I'm on page 499. Mendeleev only had 65 elements or so to work with to build his table. And the thing that was interesting about his table is he left spaces where he expected there to be an element, but there wasn't one discovered yet. Other chemists would smash your table into one piece, and it just had discord in the table. It wasn't exactly flowing the way it should be. And one of the elements that he predicted was gallium, I believe, and germanium. Those are the two famous ones. And so the reason he expected germanium on his table is because he had silicon with an average atomic mass of 28, and he had tin with an average atomic mass of 119, and he expected something in between there. And indeed, when they discovered germanium element 32, it had an atomic mass of 72.6. And you can see that on the top of page 499. He called it ecosilicon, and in fact, it was called germanium. And the density was actually 5.3. He expected 5.5. And the atomic mass was 72.6. He was expecting about 72. He was expecting a high melting point, and all of that prediction came true because his table actually functioned. Since he left spaces there, he did not have a playing card right there. It was waiting to be discovered. All right, that's it for 499. Let's go over to 500, 501. Looks like we covered most of that. And then you'll be referring back to page 500 as you go through the chemistry section of this book, or you'll look in the back of the book for your periodic table. And page 502. Now, the word periods. A period is a cycle in nature that repeats itself. And so you could say Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and then boop, Monday, Tuesday, Wednesday, Thursday. You'd expect that repetition to continue. And so it's called a period as you go across a periodic table. And that's period 2. This is period 3. And this is period 4. You can see the 1, 2, 3, 4 on the side of the table. The period is the horizontal line, and the group or the family is the vertical line. And that families have similar chemical characteristics. And in periods, the characteristics vary as you go across, but then repeat themselves as you come back and go through the next period. The electron cloud structure on the bottom of 502. Now, I've already told you that the first energy level can only hold 2 electrons. And you can see there that the second energy level can hold 8, and the third energy level can hold 18, and the fourth energy level can hold 32. And that's just the way that the electrons stack as you leave the nucleus. So the ones that are the furthest out from the nucleus are the most energetic because they got more room to roam. But the ones that are in tight, close to the nucleus, and by the way, right now I'm going to tell you, I call the nucleus mama. And mama likes to hold her babies in tight. She doesn't want to let them get away. And so the electrons that are on the first energy level, those 2 electrons, 1 or 2, depending upon the element, they're held in real tight. They don't have a lot of wiggle room. They don't have a lot of energy. Okay, mama is positive because the nucleus is positive, it has protons and neutrons. And the electrons, the babies, are negative. So the positive holds the negative because opposites attract. All right, so a guy by the name of Niels Bohr came up with this concept of stacking, like shelves on a refrigerator, the electrons as you go out from the nucleus of an atom. Now, elements in the same group have the same number of electrons in their outermost energy level. And the ones in the outermost energy level are the ones that are involved in chemical reactions. So group 1 has 1 electron in its outermost energy level, whether it's lithium or sodium or potassium or rubidium, it has 1 electron out there. Now, hydrogen also. And so hydrogen has 1 energy level. Okay, there's only 1 electron because there's 1 proton. Lithium has 2 energy levels, and it has 3 electrons because it's element number 3, 3 protons, therefore 3 electrons. And the first 2 are on the first energy level, and the third one is on the second energy level. And sodium has 11 electrons. The first 10 are on the first and second energy level, because I get 2 in this energy level. I get a total of 8 on that, 2 and 10. See, 2 and 1, 2, 3, 4, 5, 6, 7, 8. 2 and 8 make 10. And then the 11th one goes on the third energy level. You can see how the periodic table is laid out to predict drawing these models of the atom. Now, let's go to the next page, 504. Electron dot diagrams. If you take a look, hydrogen gets 1 dot, lithium gets a dot, so does sodium and potassium and rubidium and cesium and francium. If you look in figure 13, there's only 1 dot there. That represents that 1 electron on its outermost energy level. The atom, let's go and build an atom of lithium. Let's make it a lithium. Lithium that weighs 7. So you get 3 protons. And you get, if it weighs 7, you get 4 neutrons. There's your nucleus. And on the first energy level, you get 2 electrons because it's small, can only hold 2. And the second energy level, you can hold up to 8 electrons. But lithium is element 3. And since it has 3 positives, it only needs 3 negatives. So the third negative is out here on the second energy level somewhere. You just put it wherever you want. The reason I put these so far apart is because they're negatives and they push against each other. And so I put them at their extreme positions on that energy level. Now, those that are in the same group have similar properties. You can make compounds out of it. That's what it's showing you on the bottom of 504. And on 505, the regions of the periodic table are the blue are the metals, the green are the metalloids, and the yellow are the nonmetals. Metals conduct electricity, nonmetals don't. Most of the metals are solid, except for that one that I talked about, mercury, which is liquid at room temperature. Whereas there are a bunch of nonmetals that are solid, true, but a lot of them are gases at room temperature. Metalloids, they're mostly solids at room temperature, as they all are. Okay, and then metals can conduct electricity. These can't. When you mash on a metal, it flattens out, but these just pulverizes. It's just like hitting a sugar cube. It'll just go all over the place. And if it's a gas, of course, that's different. All right, so those are the areas of the periodic table. Now on the page 506, elements in the universe, it says that there's a theory that we are made of stardust. That the stars exploded and there are incubators for stars out there, but they've never been observed. They've seen supernova, they've seen Death Stars, but they've never seen a life star. So these evolutionists believe that the stardust created all the life there is. I'm not entirely in agreement with them. All right, I've covered all of chapter 16. Have a nice day.